In the last 6 years, we focused on research to find the power source to power tiny little devices. We have done nanotechnology for the last 15 years, but we make things smaller, better, hopefully cheaper. Same time, the power consumption get low. And we use battery to power. And for example, like these biological sensors, and today they can use battery to power this. If we make this 10 times smaller, what are we going to use to power this? Well, batteries are of course one choice, but when the device becomes so small, we need to find, can we harvest energy from environment to power this kind of device? What energy we have? Solar, thermal, mechanical, chemical. But for some applications, we don't have the solar, we don't have thermal, so we use mechanical energy. This includes vibration, noises, sonic wave, and to harvest those energy in a microwatt range to power a little device like that. We use these materials called nanowires. How small they are? The length is about 1/10 of your hair width, and the diameter is 500 to 1,000th of your hair width, triggered by very tiny little forces. Any biological forces, heart beating, tiny physical motion can trigger them. Utilize those, we can harvest mechanical energy. And the effect we use is called piezoelectric effect. So what is piezoelectric? Is a crystal, special type crystal, and then if you apply a force or pressure, they have a potential generate electric field inside the crystal. This effect called piezoelectric effect. We use that to convert the mechanical action to electrical action. So that's how we convert the mechanical energy into electricity. The material we use is called zinc oxide. Very cheap materials. How do you make it? Is that we use a chemical synthesis method. You can grow basically any substrate, organic substrate, metal, ceramics, whatever you are interested in, at a temperature 85 degrees C. You can see this little piece of device here. This includes the contribution of millions of these nanowires built inside this golden area. And this is put on a plastic substrate, very thin layer. The thickness of the true device is 1/10 or even smaller than your hair width. So you can have 1 layer, 2 layer, 3 layer, 1 stack, 2 stack, 3 stack. You can build this in an array. And what happens that you only need to do is anything make the mechanical deformation. So all these nanowires work in a synchronized way, and this produce 3 volts output. 3 volts is 2 AA battery volts, and we can raise the power to microwatts range, to milliwatts range. That can be used for a lot of electronics, small electronics. This is the platform technology. We're looking for a number of key area applications. For example, if you apply this one in the environmental monitoring, detection of toxic gases, toxic chemicals, tracking animals, tracking human emotions, tracking this water resource distributions, you can use this because you can make it small and they can flow with the water, and you don't have to fish them back. So let's say if you use battery, you have to fish them back because today's mostly any material that make a battery are not environmental friendly. That's another application. An application for medical devices, for example, implantable medical devices. And can we detect glucose, monitor our heartbeat behaviors, use a tiny little implanted devices. So those kind of applications, we need an individual, self-sufficient, self-powered technology that can detect that. You don't have to replace battery, but you can have millions of those ones around us. Each of them work independently, self-sufficient.